So the last thing to talk about with mean blood pressure regulation is endocrine regulation. And so again, when we say blood pressure here, we're talking about mean arterial pressure, not local flow to specific tissues. Endocrine regulation tends to be more long-term. It takes longer to initiate and have its effects. It tends to be through altered fluid volume, so altering the blood volume. And that's often. There's sometimes other effects as well, but that's where we're going to see this for the first time, I guess. Um, so I'm going to go through some of the hormones first and then talk about many of them in a little bit more detail. First one is actually an exception to that fluid volume. This is one you already know. So you already know that the effects of norepinephrine from the sympathetic nervous system targeting blood vessels and the heart to cause, so here's that right here, increased stroke volume, increased heart rate, and increased systemic vascular resistance. Just a reminder, at the same time as we have that happen, we also have norepinephrine, epinephrine released as hormones from the adrenal medulla to target those same things, same effects, right? Takes a little bit longer because for this pathway, so a little bit longer term effect, but still the same mechanisms. And we're not altering fluid production or blood volume in that case directly. Okay, a couple other ones. This is a big one. This is a complicated one. The RAS system is something we'll see in the urinary system as well, but it's important for blood pressure regulation through altering blood volume. So the kidneys will be involved because they regulate urine production and therefore fluid volume. We're going to see aldosterone specifically as its own hormone that can be stimulated as part of this RAS pathway, but also through other mechanisms. And then one effect of this pathway is stimulated ADH, antidiuretic hormone, that's produced from the posterior pituitary. That can also be stimulated through other mechanisms other than RAS. So we'll get back to this one. It's a complicated one. Okay. Next one is a pretty short one. I'm going to talk about just briefly erythropoietin, abbreviated EPO. We've talked about this a bit before. It increases red blood cell production. So if we increase red blood cell production, we are going to increase blood volume, and also blood viscosity. These two things are going to increase blood pressure. Not something that happens quickly. This happens from like altitude training, would increase EPO. This is active when red blood cells are being produced. Not something that's really dynamically regulated in the body. Okay, last one for here is atrial natriuretic peptide, ANP. This is a hormone produced in the atria of the heart, and it's the only hormone of these that responds to increased blood pressure. The rest of these are responding to decreases. We got a lot of mechanisms to keep systemic blood pressure high enough that we have perfusion to all of our tissues largely, and keeping blood flow back to the heart to keep the system going. AMP is the one exception to that responds to high blood pressure. So I'm actually going to start with that. But before I do that, I want to give you a little bit of background on this idea of how we alter blood volume via the kidneys. Introduction to it, we'll talk about the kidneys more when we get to the urinary system. But we want to at least know a little bit about how the kidneys work in terms of urine production. Very basic. So let's zoom in to a section of the kidney. And this first part here is where initial filtration from the blood occurs. So as we have increased blood flow, and so we have increased blood pressure coming through here, that's going to increase the amount of filtrate that occurs eventually to become urine. So increased blood pressure is going to increase urine production just by the fact that we have more blood flow through the kidney, basically. More urine production is going to have an effect to decrease blood pressure. right? And the opposite, lower blood flow to the kidney is going to decrease urine production to retain all we can. However, additionally, we can have this process of once this like filtrate is formed, it's not done. It's not really urine yet. To become urine, it's processed further. Reabsorption is the most important for today process that occurs where substances in that filtrate are taken back into the capillaries. So it'd be reabsorption of water is kind of the important one. Sometimes indirectly, sodium is pulled in first, then water. To either way, water is entering the capillaries and being retained in the body instead of produced in the urine. So if we have increased reabsorption, we're going to do what to urine production, I guess, first? Decrease urine and increased blood volume. So that's a mechanism by which we can regulate blood volume and thereby blood pressure, right? Increased blood volume is going to increase blood pressure. Okay, so that basic information about the kidney, we're going to see in action here. First with ANP. So ANP, again, responds to high blood pressure. That's unique in terms of the hormones we're talking about and the hormones in the body. So our stimulus, that stimulus triggers cells within the atria of the heart, so heart cells, right? These detect in the high blood pressure and produce ANP, atrial natriuretic peptide. The ANP has three effects. One of them is one on the adrenal cortex. It's going to inhibit aldosterone production. Now, we haven't seen what aldosterone does yet. There's no way to teach this information where it's all going to make sense at once. Everything refers to each other. You probably could guess aldosterone is going to increase blood pressure. So we're inhibiting that pathway. We'll see that again. We'll come back to that. But this dashed lines means inhibit. The other two mechanisms, one is a little bit quicker. This is not regulating blood volume. This is targeting the blood vessels to cause vasodilation, right? Vasodilation is going to cause a decrease in blood pressure, counteracting our stimulus. The last mechanism is targeting the kidney, causing, do you think, more or less water being excreted or lost? More. We want to lose volume in order to decrease MAP. This takes a little bit longer, lasts a little bit longer than vasodilation. Okay, that's ANP. The next one is aldosterone. We'll see ANP again here. So aldosterone is a steroid hormone that's produced in the adrenal medulla. You remember the adrenal medulla is where corticosteroids are produced. Aldosterone is actually a derivative of those. So this kind of makes some sense. It's somewhat similar molecule to cortisol, and it's actually stimulated by the same pathway that stimulates cortisol. So the hypothalamic pituitary adrenal axis is one of the pathways that stimulates aldosterone in response to stress, just like so cortisol and aldosterone are both within that adrenal cortex. So that's one pathway for which it's stimulated. This one we're going to skip for now. So I'm actually going to cross that out for now as well. We'll get back to that probably when we get to the urinary system. Here's ANP over on the right. So increased blood pressure results in ANP production, which inhibits aldosterone. And then the last one is that most complicated one. So the RAS system. I don't know why I did it down that way. Renin, angiotensin, aldosterone system. So low blood pressure triggers the kidneys, which produce renin. Renin is a hormone produced by the kidneys. That renin initiates this cascade of events that results in angiotensin 2 production. We'll see angiotensin 2 actually next in more detail. It has more effects. One of its effects is to target the adrenal cortex to produce aldosterone. That's what's shown here. Regardless of the stimulus, aldosterone targets the kidneys to increase, it says absorption here. We've been calling it reabsorption. So in that kidney, that tubule of the kidney, this is the capillary. We're increasing reabsorption of sodium, and then water follows that. So we're thereby increasing blood volume and increasing blood pressure. Not too bad, right? Okay, gets another level more complicated because we look at other mechanisms. We're going to look at RAS more closely, and what's happening with the kidney. So renal mechanisms mean what's happening at the kidney here. First, I will really quickly say on the left, this is the same idea I said when I introduced the kidney. Decreased arterial pressure, its mean arterial pressure, is going to result in decreased filtration, meaning decreased filtrate produced in the kidneys. So we're not going to get as much fluid in the kidney tubules. So less can become urine because there's just less urine, less filtrate. That's going to then have just an intrinsic mechanism to preserve blood volume. Right? When you're dehydrated, you pee less so that you preserve what you have. The indirect mechanism here, the renin-angiotensin-aldosterone system, S for RAS, is over on the right. So stimulus is going to be decreased mean blood pressure. And you've already seen this, right? That this causes decreased baroreceptor firing, inhibits those baroreceptors. That is going to cause a response of the sympathetic nervous system. That's going to result in the vasomotor center and cardioacceleratory center doing their thing. Here, we're looking at something else. The sympathetic nervous system also activates renin release from the kidneys. So this is one cause of the release of renin. We'll see others later. Renin is going to activate angiotensin 2 indirectly. This is a pre-peptide, basically, of pre-hormone that is activated by renin. ACE is another and is an enzyme that also is involved in the activation of eventually angiotensin 2 is what's active. If you've heard of ACE inhibitors, they are a medication taken to inhibit ACE. They would decrease angiotensin 2 production and thereby decrease blood pressure because they're preventing this mechanism that ultimately is going to increase blood pressure. They're preventing that from happening. So that's why I like to include ACE here. Some people have heard of ACE inhibitors. So renin's initiating the production of angiotensin 2. Angiotensin 2 has 4 effects. There we go. I'm going to number these 1, 2, 3, 4, but not do them in order. I actually want to start with the quickest one is number 4. We're going to have vasoconstriction, right? Increase resistance to increase blood pressure. Whenever you have a hormone that you want to know what it does, look at your stimulus and then have it either vasoconstrict or vasodilate based on what makes sense for responding to that stimulus. And you could be right about what the hormone does. So that one's quick. Number 1 is that RAS system. That's what this is named for. So renin, angiotensin, aldosterone system. So angiotensin, like we saw in the previous slide, targets the adrenal cortex, which produces aldosterone, which causes sodium reabsorption. Water follows and increases blood volume. Less urine is produced because of aldosterone. Okay. The next mechanism here is an angiotensin can trigger antidiuretic hormone production from the posterior pituitary. ADH, antidiuretic hormone. You already know about what this does. We saw it early this semester. It's going to cause water reabsorption directly in the kidneys. So retaining water, again, less urine. Does that by water directly instead of through sodium. We'll see these both again, aldosterone and ADH in the urinary system unit. Okay, and then the last mechanism is increasing thirst. So angiotensin targets the hypothalamus, causes you to be thirsty. If there's water available, you're going to drink water and increase blood volume. So pretty cool, many mechanisms to respond to low blood pressure. You can see how important it is to maintain systemic blood pressure. And the RAS system has this variety of responses from vasoconstriction, which you're not aware of, to urinating or how much you're urinating, to thirst, which is a behavioral change, all to address the same stimulus.